Hello Leetcoders. So today we are going to solve 26-day problem in the Leetcode May challenge, and the title of the problem is Contiguous. So before I proceed, I'm just going to tell you that today's video is going to be very short and sweet and just going to be like really solution oriented because I'm really exhausted today because of so much hot and temperature outside. So I just want to get some sleep. So yeah, we are given a binary array. Find the maximum length of contiguous subarray with equal number of zeros and one. So it is basically asking us to find a subarray which has equal number of 0 and 1. So if we simply take zeros and 1, so because this is subarray, so we need to detect some of the keywords. So one keyword is subarray and one is the sum or equal number of zeros and 0 and 1. So subarray means it has to be continuous. So like you cannot skip any item in between. Equal number of zeros and 1. What we can do is we can assume 0 as -1 and 1 as we can assume 1 as 1. And if we sum them up, it will become 0. So whenever the sum will become 0, we know that we have found the subarray which has equal number of zeros and 1, right? So total sum equal to 0. So in these lines only, one of the basic approach or the brute force approach that come in our mind is to use two for loops. The first loop will keep a track of the start index, and the second loop will keep a track of the end index, and we keep finding each of the subarray, and we keep finding the sum. So let's say I have this example like 0 1 1 1 1 0 and 0. So here if I find all the subarray, I will initially start from I will be here, my j will be next to I. So my first array will be 0 1, then it will be 0 1 1. This way I find all the subarray, and whenever my sum will become 0, so in this case my 0 is corresponding to -1 and 1 is 1, so my sum is becoming 0. So whenever my sum is becoming 0, I will calculate the length. So here the length is 2. Similarly, when my I will be here, sorry, let me just represent I with the same color so that there is no confusion. So my I is here and my j will go here. There will be a case like this. So this will be my subarray, which is of length 4, and this will be the maximum subarray that I will be having. The problem with this approach is you are using two loops, so the time complexity will be n square, and though the space complexity will be constant because we are not using any space, so this will be space, right? But this n square is way too much, and this is not acceptable in an interview or in a practical situation. So let's just optimize it further. So I'm writing the same example here again. This is my example, and the faster than n square will be linear solution, right? That will definitely be faster than a quadratic solution. So to make it linear, we so we have to use space. So let's see how we can do that. So let's say we have a hash map. So our hash map initially had 0, minus 1. So 0, which is the key, is corresponding to some current sum. So let's say for 0 the sum will be minus 1. For till here the sum will be 0, because 0 will be minus 1 and 1 will be 1, so sum will become 0. Then from here to here sum will become 1, because you have 2 1 and 1 0, it will be 1. So it's like this. So the key is the current sum, and the value is basically the index where you are getting that sum. So in this case, uh, my so this is my initial position, initial, and then when I will be at 0, my hash map will become minus 1, comma. So minus 1 will be my key because the sum is minus 1, and the value will become 0, right? And we will also be tracking a global sum. So let's say my global sum variable is here. So this sum is actually the global sum, which is coming from here, right? So my current sum, uh, let's just walk through the loop and calculate each of these values and see how we can solve this problem. So I have, so basically I have my pointer at 0th index first, 0th index. So my sum will become 0, and my sum will become 0, and my sum, now there is, oh sorry, my sum, now let's just start from 0th index. Now at 0th index, since whenever my element is 0, I am taking that as minus 1, so my sum will become minus 1. And since I do not have a minus 1 in the hash map, I'll put that sum in the hash map, and the index is 0 because I'm getting that sum at index 0. Now I move to I equal to 1. I have 1 there, so my sum will become 0. So minus 1 plus 1 will become 0. I already have 0 in my hash map, and this is my index 1. So let me just put all the indexes here, right? So this was my 0th index. So now my this 0 will become 1. So let me just remove this, right one here, right? So I have 0 1. Oh wait, so this actually this will become my current index I minus whatever is the existing value in the hash map. So let's say I denote hash map by h of sum. So this will become my current value of hash map. H of sum will become this. So initially here it was minus 1, and my I value is 1. So I 1 minus minus 1 will become 2. So my I will become 2. So my 0 key will correspond to a value 2, right? And whenever we are getting a sum which is existing in the hash map. We will also calculate the maximum length, which is a global variable, and also the output that we will return from the function. So this will be maximum of whatever is the maximum length value we have, and I minus this value, right? H of sum, because this is my if you look at this example, I'll explain you how this is working. Just bear with me for the time being. So basically this H, when when the key do not exist in a hash map, that means we are getting a sum from starting position to that index, right? So let's say if we go to index 2, so now if we go to index 2, we have a sum that is 1. Our sum will become 1. Now 1 is not in the hash map, right? So we'll put the 1 in the hash map, and the 1 is sum from starting position, 0th position to the current index, right? So we have the current index as 2. Now we have 3. We come to 3, third index, and our sum will become 2. We do not have the current sum in the hash map, so we put the current sum in the hash map, and we are getting that sum at index 3. So my index will be 3. Now we again move next in the list. We reach to a 4th index. My sum will become 3. I have not seen this sum before, so I put that sum in the hash map. That sum has occurred at index 4. I'll put 4 here, right? Now I get 0. So this is important case to understand. So when I get 0 at 5th index, now 0 will correspond to minus 1, right? So I will decrease 1 from 3. So my current sum will become 2. I have seen 2 before in the hash map. I have seen 2 at index of 3, which means from third index onward to the current index. So if my third index is 1, 1, 0, 0, so I am kind of reconstructing the given list. So this is my third index, this is my fourth index, this is fifth index, this is sixth index. So since I have found my sum at third index, that means from third index to current index, from third onward to current index, I have a sum which is 0, because then only this is possible. So we will basically decrease the current index. The current index is what? 5. And my existing index is 3. So 5 minus 3 equal to 2. This is the length of the subarray that I have. So this function will be called, this line will be called again, and my maximum length will get updated, right? So now I again went to 6th index, 6th position. I get 0. My current sum is 2. So I decrease minus 1 from this. My current sum will become 1. And I see, oh my god, one is already in the hash map. So, and this one is corresponding to an index of 2. So, which means from third index onwards, 2 plus 1 index onward to the current index, we have a zero sum subarray. So, from 3 to 6, we have a zero sum subarray. So, 6 minus 2 equal to 4, which will become this value, will become my maximum length. I hope this makes sense. We will write code for this and it will become super more intuitive, or it will become crystal clear in your brain. So are you ready? Are you ready for this? Let's do this. So let's first take our maximum length variable, which can not be less than 0, because like if we don't find any 0 and 1, that means we don't have any element which is 0. So max length is 0, and then we have our global sum. So I'll say global sum g sum, which will be 0 initially, and then I also need a hash map. So my hash map, let's just have the same naming convention. I will have 0 comma minus 1 initially, right? Now I'm doing a for loop on the elements of the list, or here it should be nums, and then I will update my gsum plus equal to 1 if we are having current element as -1, current element as 1, else we will decrease. So if my gsum already exists in hashmap, that means we have to calculate the maximum length, which will be maximum of maximum length and the current index minus the existing index we have, hashmap of gsum, I guess. And then if that is not the case, we will simply put the current sum in the hashmap. So my gsum will go into hashmap, and the current position at the end, I will simply return my maximum length. I hope this makes sense. Let's just try to run it once. Working for this, let's submit it. Is code accepted? Okay, it doesn't matter. So I hope you got the solution. Please like the video if you really understood it correctly, and if you please mention in the comment section below how you can solve this problem in a different solution, or how if you have any doubt or problem. And also subscribe this channel for keep getting more such videos and content about programming.